Okay, let's take a look at problem 22-1A, which deals with a CVP analysis and graphing problem. In this one, we have Edge Equipment Company, and it's a manufacturer and marketer of a number of rope products. Management is considering the future of product XT, a special rope for hang gliding, and it's not been as profitable as planned. Since product XT is manufactured and marketed independently of the other products, its total cost can be precisely measured. Now, next year's plans call for a $150 selling price per 100 yards of XT rope. Its fixed cost for the year are expected to be $200,000, up to a maximum capacity of 550,000 yards. Forecasted variable costs are $100 per 100 yards of XT rope. Let's look at the first requirement. Estimate product XT's break-even point in terms of sales units and sales dollars. Okay, well, there's break-even and sales units. Okay, what's that equal to? What's equal to fixed cost, right, divided by contribution margin per unit. Okay, so if we want to solve that, we have to determine the fixed costs, right? And the fixed costs, let me just put an equal sign in here. The fixed costs are equal to 200,000 given in the problem, right? And contribution margin, I'll put the division sign there so we can see it, would be equal to contribution margin per unit. Let's calculate the contribution margin per unit. And that one is going to be equal to the $150 selling price per 100 yards less the $100 variable costs. So that's $50, right, per 100 yards. Okay, so we know then that we can put in $50, say in this cell here, and then to solve the problem, we would take the 200,000 divided by the $50, and we come up with a value of $4,000, and that's in units. Okay, so right there, and 1 unit would be 100 yards. I probably should spell that out. Okay, now let's solve the break-even in sales dollars. And what I'm going to do is just copy this down and make some changes. Okay, so we have sales dollars, and that's going to be equal to fixed cost divided by the contribution margin ratio. And I see I have a typo up here. We should fix that. Okay, let me lock in the titles. We'll do a freeze pane here. And then I can slide this down so you'll be able to see as we work through part B of this problem. And this one actually is part B. If I slide back up, we'll see that that's part A. Okay. We'll slide back down now to give ourselves a little bit of room. Alright, so break-even in sales dollars is fixed cost divided by contribution margin ratio. So we know we can pull that 200,000 from above to get there. We'll drop the division sign again, just so we can sort of visually see what we're doing. Now, what's the contribution margin ratio? Well, let's compute that. Give us some room again. contribution margin ratio is going to be equal to the contribution margin unit, right, which is $50, divided by the selling price, which is 150. So if we divide that out, I'll just put an equal and we'll calculate it here. We'll take the 50 divided by 150, and what do we get? We get 33%, and 33.33 is probably as close as we want to get. So if we then drop that here, right, fixed cost divided by the contribution margin ratio, we can get the answer to part B, which is going to be that cell divided by that cell. And we wind up with 600,000. Now, this is in terms of sales dollars. We don't need pennies, so I'll put it back. And that's break even in sales dollars. I'll just bold that. And that takes care of part B. So let me see if we can get it all on the screen. It doesn't look like we can. So part A, it's 4,000 units. Part B, it's $600,000 is the break-even point. Okay, now let's take a look at the second requirement, which is to prepare a CVP chart for product XT, like one shown in the textbook. Use 550,000 yards as the maximum number of sales units on the horizontal axis, and 900,000 is the maximum dollar amount on the vertical axis. Okay, well, there's lots of ways you could put this graph together. You could use the formula that we have and drop it into Excel and then use Excel's charting. You could use the formula in a calculator and use Microsoft Paint to draw the graph. Now, to save time in terms of the demo, I'm not going to do the graphing, but I will show you what it looks like. So let's go over to the next page where I've cut and pasted what the graph should look like. Okay, so in this example of CVP chart for the Edge Equipment Company, what you see is the total cost will start off at the break-even point of 200,000, right? And then it will move up in a ratio of what? $50 per 100 yards. Oh, and I have another typo here, okay? So we know the fixed costs are 200,000, and then we know we're going to earn $50 contribution margin, and we see that $50 improvement as the volume goes up on this line right here. Now, if you also wanted to graph the sales line, sales would hit the intercept because sales are equal to what? $150 per unit, and each unit is 100 yards, and then that one will go up sort of in this directly increasing manner. And what that tells us is where the total cost equal to sales, we've achieved the break-even area. So this area in here represents a loss to the company, and as we move above break-even volumes, this area in here represents the profit. Okay, now why don't we take a look at part 3. Again, I'll slide prepare a contribution margin income statement showing sales, variable costs, and fixed costs for product XT at the break-even point. Okay, so first I would put a title on there like Edge Equipment Company. Okay, and why don't I just center that for now? And the next one this would be a contribution margin income statement, and we're going to do it at break even, right? For product XT. Okay, so some kind of title might be worthwhile, and then we would drop in the information. Now, why don't we drop in sales? I think I'll underline this so we can see it a little bit. I'm going to compress this because we don't have a lot of screen room to use. Okay, well, sales would be equal to 4,000 units, right, at $150. Well, I keep forgetting that doesn't like certain formatting. Okay, and variable costs are equal to that same 4,000 units at $100 per unit, right? Put an equal sign in, so it'll take the formula. Let's format that. In fact, I think I'll format all these cells for now. And that will get us our contribution margin, which is simply the subtraction of those, right? So at 4,000 units, we would have contribution margin of 200,000, which gets us to our fixed cost, which we know are 200,000, right? Once we deduct that, we would compute net income, and net income is going to be 0 since we're doing it at break-even. Okay, so that takes care of part 3 of the problem. Part 1, A and B, appears above, and the graph in part 2 appears there.